Yeah. 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 Let's get ready to stream. Let's get ready to have some fun. Yes. All right. All right. How's everyone doing today? Hope you're doing well. Hope you're ready to dive into learning some C Programming and Emacs fun with me. If you are, let's go ahead and we will start. So, we'll just look at what we did. So, where we were yesterday, You have to let me know if the music too is not is loud enough or not. Is again in a good place for today. What we did was we were looking at copying strings, and I was confused when we were looking at the initialization point here, where he's talking about the strings literal versus the string array. So I looked that up. I did some research on that today, and it turns out that, and I'm sure he said it. It was just confusing to me, but when you do the pointer initialization here, it is put into memory, into like read-only memory by the compiler. So it's actually a literal compiler. When it compiles it, puts it into like the code memory, and you can't execute code because this is literally just a copy inside of the code. You can't execute the memory inside of a code typically, from what my understanding is so far. Whereas the array one is a compiler provisions enough memory to hold that array in there within the running memory of the program, not the code memory. So I think that's my current understanding. If things change or if I need to redo my understanding, then we can revisit it at that point. But then when I look at string length, string termination, and we're gonna go and start with the structs today. I did structs, and we're gonna start with a file input output. Another thing I was messing around with is the timer. As you can see, the timer that we used today started off with a little bit more of a actual with an actual point of where the time of the stream is actually going to start. So that's nice. So now we have the actual time that the stream is starting, and I want to do a kind of stream ending warning signal at some point, but I'm gonna have to look into what the complexities of adding that are. So for now, we're just in Emacs here. Let's go back to the home, and then we'll go to source. Do we have C? Yep, we have C. So yeah, we have learning in there, and we were doing strings. So let's do a file.c, I guess. And then of course we want to just get into the habit of always practicing the obligatory typical C program, right? Return 0, and you can do printf for hello world. So we can do hello world, right? Just that, and then we can compile. And we're just going to change the name of it from file to file.c, C89 pedantic, all the extra errors. And then everything looks good. So we'll go to our terminal and we should be able to run it. File. Hello world. You know what I'm always forgetting is to put that escape character for new line. Okay, so we have that. So then let's look at the document here. We'll read through it, and we've already seen some examples of I/O with printf for doing I/O to console, but we'll push those concepts a little further this chapter. When we do any kind of I/O in C, we do so through a piece of data that you get in the form of a file pointer type. This file star type holds all the information needed to communicate with the I/O subsystem about which file you have opened, where you are in the file, and so on. The spec refers to these as streams, i.e. a stream of data from a file or from a source. I'm going to use files and streams interchangeably, but really you should think of a file as a special case of a stream. There are other ways to stream data into a program than just reading from a file. We'll see in a moment how to go from having a file name to getting an open file for it. But first I want to mention 3 streams that are already open for you and ready to use. Hold on, let me turn my glasses off. My Meta glasses always. Battery 15%. Please charge now for full functionality. Okay, where were we? We'll see in a moment how to go from having a file name to getting an open file star for it. But first I want to mention 3 streams that are already open for you and ready for use. File stream, standard in, standard out, standard error. We've already been using these implicitly already. It turns out, for example, these 2 calls are the same: printf, hello world, and fprintf to the standard out, hello world, printf to a file. Interesting. So let's look at that real quick in the documentation. So we know printf the documentation for printf does say, oh look, printf, fprintf, dprintf, sprintf, sprint. Okay. So include standard int. So okay, so if I went to man fprintf dot 3, it's going to say this. Yeah, it's going to say the same one. So, and it does say here standard out. See right there, printf and vprintf write output to standard out, the standard output string. Fprintf and vfprintf write output to the given output stream. Sprintf, snprintf, vsprintf, and vsnprintf write to the character string stir. The function dprintf is the same as fprintf, except that it outputs to a file descriptor, fd, instead of to a stream. The function sn, okay, yeah, so that's what he was talking about with that different stream concept. So we've actually seen, it turns out that these 2 calls are the same, printf and sprintf. Let's just verify that by testing it. So we'll say, okay, so you pick out the standard out, right? And then I could do hello world again, and this one should print out, like he said, from the quit, and yeah, hello word, hello word, hello there word, how are you wording to do? Sometimes spelling is hard, but more on that later. Also, you'll notice that both standard out and standard error go to the screen. While this seems at first either like an oversight or redundancy, it actually isn't. Typical operating systems allow you to redirect the output of either of those into different files, and it can be convenient to be able to separate error messages from regular non-error output. For example, in a POSIX shell like shell, K-shell, bash, all these shells have really weird names. On a Unix-like system, we could run a program and send just the non-error standard output to one file and all the error standard output to another file. So foo could be the program. We could say output.txt goes there and the errors.txt goes there. This command is Unix specific. For this reason, you should send serious error messages to standard error instead of standard out. More on how to do this later. So I can just pipe what they're saying. So I don't have anything here. So if I say I want file to pipe to output.txt, then I can cat output.txt and it's going to have that information. That's actually got to be one of the fastest ways to write to a file. That's pretty cool, actually. I didn't realize, I mean, I knew about piping, but I did not. Huh. Isn't that cool? Don't you think that's cool? Because with like a Python or something, you would open a file descriptor, you would do a write, read line, write lines, and all this. Because the printf on the system is set to automatically go to there, then it does that. Now, in a POSIX shell, it does that. What about in Windows? So let's look into our Remina. Just take a little bit of a move here. Let's look in Remina and see if we can't printf. Okay, so it's there. So do we have pipes and same in string.exe, hello world, string.exe, pipe it to foo.txt? Oh, we do? Wait, no. Do you have pipe symbols in? I don't think you have in command dot. Oh, wait. Microsoft Windows. Hello world. Okay, so notepad. Foo.text. Yeah. So you do have the pipe similar in Microsoft, but I wonder if it's there for backwards compatibility. I'm not sure. Let's see. If I just do help. 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 When did that come to Windows? That's kind of cool. Because obviously with Bash, we know all day long we could do it with Bash. Right, so like, does this have GCC on it? No. Does it have CC? No. Does it have Clang? No. It doesn't have any. Tiny C? Tiny? No. Okay. Alright, so let's go to back to the thing. For this reason, you should send serious reading text files. Streams are largely categorized two different ways, text and binary. Text streams are allowed to do significant translation of the data, most notably translations of new lines to their different representation. Text files are logically a sequence of lines separated by new lines. To be portable, your input data should always end with a new line. But the general rule is that if you're able to edit the file in a regular text editor, it's a text file. Otherwise, it's binary. More on binary later. So let's go to work. How often do we open a file for reading and pull data out of it? Let's create a file called hello text that has just this in it. Okay. Hello text. And hello world. Okay. And let's write a program to open the file, read a character out of it, and then close the file, and we're done. Okay, so file pointer, fp equals f, open, hello.text, r, int c equals f, get c from the file pointer, okay. Print f. Okay, so here's my question. When you do that, does it move it? So if I go get int d equals f, get c, file pointer, print f, %c, n for d, is that going to be the next character in there? And then we got to close it. F close, file pointer. Recompile. Mixed declaration. Where do I have a declaration? Here. Where's mixed declaration? Oh, that one? Oops. That's this one here. Recompile. Another mixed declaration. Where? Int c. C, D. Recompile. There we go. Okay. H and E. Huh. Yeah. So it does, when you get the character, it moves the pointer along, so it must be something kind of like, ooh, you know what, I need to make a scene for writing. But I mean, I have the screen there, so I could just open up journal. Okay, so we got our, whoa, hold on 1 second. My pen input's the wrong direction. Work area, this will be over there. There we go. Okay. There we go. So, so you have this file, right? File here. It's got some text, like hello world, right? And then it has like a CR, CF, or whatever the character ending. I can't remember. Whatever the new line character is for Windows. And oh, is there a dark mode for this? Journal tools, plugin, edit, preferences. Is there a dark mode? There isn't. I'm sorry. It looks like it's probably hard for you guys to see it. It's really bright. I will fix that. I will put that in my notes, and we'll fix that next time. I don't remember. It's whatever the line ending encoding is in here. Okay. And then so you have this file pointer. You named it file, and it's, I'm guessing, here, and you say give me that char. So then you say get, what was the command? F get char, right? F get char for the file pointer, obviously. And then it returns that char, and then it moves to this next one. So now it's pointing here, and this one's gone. So then you do F get char again, and then it grabs that one, and then you have it, and then the pointer goes here, and this one's gone. I think that's how it works. So it's like it's traversing the memory locations, or something like that. That would be cool to develop our own of that eventually once we get good at C, but we're not there yet. I just wanted to make that test just so I could verify that that's what we're looking at. Okay. So now we'll go back to where we were. Okay. See how when we open the file, it returned the file to us so we could use it later? I'm leaving it out for brevity, but I'll open and return no if something goes wrong, like file not found. So you should really error check it. Oh, let's do that. So let's error check it. Let's assert FP is not equal to 0. And let's say give it the wrong file. We don't have that file there. Oh. Ah, assert. It's in a header. Makes sense. Include assert.h. That's nice to read. The compiler recommended for me what I was missing. Okay, but now since that file doesn't exist, yeah, it failed. Yep. Okay. Okay. Also notice the R that we passed in. This means open. Okay, so now if I go back to the hello, make it the right thing. Recompile. And obviously we could pass them in through command prompt, but I'm not sure how to do that yet. This time it worked. Also notice the R that we passed in. This means open a text file. Open a text stream for reading. There are various strings we can pass to fopen with additional meaning, like writing or appending and so on. Ooh. I did not know that would give me some DuckDuckGo love around here. Also notice the R that we passed in. This means open a text stream for reading. There are various strings we can pass to fopen with additional meaning, like writing or appending and so on. After that, we use the fgetC function to get a character from the stream. You might be wondering why I've made C an int instead of a char. Hold that thought. Finally, we close the stream when we're done with it. All streams are automatically closed when the program exits, but it's good form and good housekeeping to explicitly close any file yourself when done with them. The file keeps track of our position in the file, so subsequent calls to fget would get the next character in a file and then the next until the end. But that sounds like a pain. See if we can make it easier. Oh, so that's what it's. Remember what we verified about the pointer moves on that whatever that object is, that struct. It's moving from character to character. So we've just verified that that's the case. There is a special character defined as a macro, EOF. This is what fgetC will return when the end of the file has been reached and you've attempted to read another character. How about I share that fun fact now? Turns out end of file is the reason why fgetC and functions like it return an int instead of a char. End of file isn't a character proper and its value likely falls outside the range of char. Since fgetC needs to be able to return any byte and end of file, it needs to be a wider type that can hold more values, so int it is. But unless you're comparing the return value against end of file, you can know deep down it's a char. Yeah, that makes sense. Alright, back to reality. We can use this to read the whole file in a loop. Oh. So we open it again, and then while C is not equal to end of file, because that is a macro definition, print the character and then close. Okay, so let's do that. Whoops. Oh, those. I need to do the whole thing, right? Okay, so let's go now and say that while C equals fgetC of file pointer is not equal to end of EO file, then print fc for C and then close. Recompile. Warning, unused variable. Oh yeah. Recompile. Oh. Recompile one more again. One more again. Hello world. So we wrote it to the file, we took it out of the file, we wrote it to the file, we put it in the file. We're doing file stuff around here, folks. We're doing file stuff around here, folks. I am going to... Let's go ahead and... Let's go ahead and take a small break. I'm going to take it to, let's see, Do a 5-minute break. Oh yeah, so this is the code that I made for the change here, but as you can see, it's only currently working with it's only currently working with 610.5 300. It's only currently working with it's only currently working with the strong hour, not like the full thing. So I'm going to change that. So let's go ahead and take a break. I'll be back in about 5 minutes and we'll continue on for a little bit more time. Are you upstairs or down here? Okay, that is not the right message. Sorry about that. Let's see if we can change the message. Okay, that should be the right message. Okay. I don't even know if it's going to take me that long. Just got to fix a few things here. And then got to figure out what we're going to eat for dinner. What do you guys think I should eat for dinner? I'm really just talking to myself, aren't I? Yeah. 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 Okay, I think I'm back now. Yeah. Yeah. I wish you could. Okay. Okay, I'm back. Let's continue on with the programming that we were doing. What programming was that, you say? Well, I'm glad you asked. We were messing with the file pointer and the files thing object. So let's get back to that. Okay. So we just did the writing it out using the loop. That was fun. Let us now, if line 10 is too weird, just break it down starting with the innermost nested parens. No, it's not too weird for me. We just crammed into a single. This might look hard to read, but study it. It's idiomatic C. Compare that against, we've just crammed into a single line. This might look hard to read, but study it. It's idiomatic C. And running this, we'll see. But still, we're operating a character at a time, and lots of text files make more sense at the line level. Let's switch to that. reading a line at a time. So how can we get an entire line at once? F gets to the rescue. For arguments, it takes a pointer to a char buffer to hold bytes, a maximum number of bytes to read, and a file star to read from. It returns null on end of file or error. F gets is even nice enough to null terminate the string when it's done. Let's do a similar loop as before, except let's have a multi-line file and read it in a line at a time. Okay, let's do that. Let's do the, what we can say, quote.text. Quote.text. There it is. Okay. And here's some code that reads the line at a time and prints out a number before each one. Okay, so big enough for any line this program will encounter. 10,024 bytes. Int line count. Quote. Okay. But how does it, because is F, is it reading? Okay, so I have a question about lines, about this F gets. Is it reading the line terminator? Because the character was just taking one character at a time, right? So if we did the character, so let's, I want to do a test real quick. So if I go back here and I do a new line, does that give us a termination character? Yes. No. Wait, what's hello? Well, I don't, it looks like it might give us a termination character. Let's print out the integer value for each one of those. D. And then recompile. Oh, yeah. That's interesting. So 10. Hello world. L is 108, right? L is 108, so D is 100. Exclamation point is 33, and 10. So 10 must be the ANSI code. No. No. Ask ANSI. ASCII. It's ASCII. ASCII codes. Line feed. So that's line feed, which makes, so 72 was H. Yes. So that is the character. So the char would have given us back, or the char does give us the line feed. So it must read the line feed then when we do the other one. So let's, I want to make a quick program to do that. So let's do lines.c, and we're going to include, and I want to do it from memory now because we've been looking at this enough. include standard .h. We'll also include assert, so we don't try to open a file that doesn't exist. And we'll do int main void, right? And then we want a file pointer. We want int. Let's say it's the buffer 1024. This is our line buffer. This is our line buffer. Okay. Oops. This is our line buffer, and I think that's all we need. Okay, so we need to open. F open hello dot no quote dot text. I don't know what it's called. Quote dot text. Quote dot text R while F. Let me look at the documentation again. F get C. C also. Gets F. F gets. F gets. Man, F gets. Okay. F gets. So F gets takes in the that's the FP. Yeah. FP equals okay. FP size of B FP equal to file go back here. F gets S size of is not equal to null, okay. Which is 0 for here. I don't think there is a null. We'll see. I don't think there's a null in C99. Print F %D and then the %S. And then we're going to increase the line count and then print it and then S. Close this. F close. FP. See how many errors I have. Oh, it's gonna be a char. Oh, because that's the buffer. Yeah. Okay. Okay. Oh, that's lines. A wise man can learn more from a foolish question than a fool can learn from a wise answer. Very interesting. Very interesting. Very cool. It's very cool. Yes. Okay, so no chatters today, huh? Everyone's gone. Let's say that we want to continue on now. Because it just reuses that buffer and finds the it reuses the buffer and it just finds the line ending thing each time. So f gets okay. Cool. I like it. Formatted input. You know how you get formatted input printf. Excuse me. Sorry. You know how you can get formatted output with printf, and thus fprintf, like we'll see below. You can do the same thing with fscanf. Before we start, you should be advised that using scanf style functions can be hazardous with untrusted input. If you don't specify filled widths with your %s, you could overflow the buffer. Worse, invalid numeric conversion result in undefined behavior. The safe thing to do with untrusted input is to use %s with a filled width, then use functions like strutto or strutto to do the conversions. Let's have a file with a series of data records in it. In this case, whales with name, length in meters, and weight in tons. Whales.txt. Yes, we could read these with fgets and then parse the string with scanf, and that's more resilient against corrupted files. But in this case, let's use fscan f and pull it in directly. The fscanf function skips leading white space when reading and returns end of file on end of file error. Big enough for any language program counter, float length, Wells text, fscanf, file pointer, %s, %f, %d, name and length, and mass is not equal to end of file. Name and length and mass print well tons meters name mass length. Okay, let me that's actually kind of cool. So that's how you do formatted input in C. What? So, but what? Okay, so let's do man scanf input string format conversion. Family scans formatted input according to format described below. A lot. Okay, so man fscan f family scans formatted input like scanf, but read from a file. It is very difficult to use these functions, and it's preferable to read entire lines with fgets or getLine and parse them later with scan 3 or more specialized functions such as stro. Scanf function reads input. It is very difficult to use these functions correctly. On success, these functions return a number of input items successfully matched and assigned. This can be fewer than provided for or even 0 in the event of an early matching failure. Errors, attributes, standards, caveats. Makes it difficult to distinguish new lines from other white space. This is especially problematic with line buffered input like the standard input stream. These functions can't report errors after the lost non-subrisk. Threads. Function. fscanf file. Stream, yep. And then format. Constant char pointer format. Scans formatted input like scanf, but it's very difficult to use these functions. And that's more resilient, but in this case, let's just use pull it in directly. Oh, okay, so this isn't the preferred way to do it. It's just an example of how to do it. Okay, so we need to create the whales. Whales text. And then copy that. And then let's call it Wales.c. Include not that big. Let's do what? How many? 100 bytes is enough. Oh, but we should do aligned. So 32. I don't know. Float length. Int mass. FP equals open Wales.text. Scan F of the pointer, and then we have percent S, percent F, percent D. Okay, that would take the name, and then we do on a pointer the address of length. Of mass. Okay. It's not equal to end of file. Then we'll print it formatted. Print F percent S whale percent D tunes percent .1 float meters. Name, mass, length. And we close. Then we compile. Wales. Just to see. Oh, F open. Yes, I did. Oh, it's not supposed to be long. It's supposed to be just a float. .1 float. Okay, so now if we do Wales, interesting. Sorry, my ear was a little bit sore right there. Okay. Interesting, interesting, interesting. People are viewing for 26 seconds. That's it. Okay. Alright, so let's look at doing the same exact thing. Open the text file again. P equals F open. Whales dot text, but this time I want to do it using the line thing that I was talking about. While F gets I need is it chars? Char buffer 1024. Okay. B size of B FP not equal to end of file. What is that strobe function that I was talking about? What is that strobe function? The strobe function converts the initial part of the string and pointer to a long integer value according to given base. The string may begin with an arbitrary. What? Convert a string to a long integer. Well, that's not what I want. Man. There we go. String to scanf. scanf. Okay. Input string format conversion. Okay. Conversion specifications. Linear stored in locations pointed to by the pointer. Okay, so the string and then the format. Okay, so it's the same thing essentially. And then scan F. Scans input. This format must be of a type that is appropriate for the value returned by the corresponding conversion specification. Oh, because we still have to do the thing. Scan scan F B percent this percent F percent D name and length and length and mass. So I don't understand how it's any harder though. Do you? Comparison between a pointer and integer? Okay, so pointer and integer while f gets is not equal to no, it's not equal to no. Okay. Okay. Cool. So we didn't get to the writing text files. We'll do that tomorrow. And then what's left in the contents. Two volumes. We're going to go through the tutorial part in order. How are you going to? Does it go in order? Okay. How are you getting chapters less important? Go in order. So we have 9.5 to finish, and then type def stuff to start, and then pointer arithmetic. And then I'm gonna want to make a timer, a better timer for the stream that is I don't know if it's better, but that would be like using SDL or something like that. If I have enough so all right. Well, I hope everybody enjoyed the stream today. I had a lot of fun. I hope you had a lot of fun. I look forward to streaming with you guys again, and I hope that we can continue to move forward with this. Sorry, I was looking at the stream and trying to do something, but if you like the video, go like the video. If you like what you see here, you like figuring out coding and just hanging out in streams and having fun, subscribe and follow me, and we will talk to you later. Bye, everybody. I'm out of here.